Okay, lesson 7.2. So we're going to write equations to represent relationships represented in tables, or write equations for function tables. So this says Luciana earns $8 per hour walking dogs in her neighborhood. The table shows the relationship between the number of hours, H, that she walks and the total amount, D, in dollars she earns. To write an equation that relates the variables H and D, first determine the rule that describes the relationship. So for this lesson, we're given our input-output, or independent and dependent values. What we want to find is the rule. So how we find the rule is we find the change in output over the change in input. So what we need to do is find the change in our output values. So this goes up by 8, this goes up by 8, and this goes up by 8. And then the change in our output values each go up by 1. So then we do the change in our output over the change in our input. But you need to check that they're all the same. So in this case, all of them would be 8 over 1, which is 8. So 8 is going to be part of our function rule. So because repeated addition can be written as multiplication, what we're going to do is multiply what we got by our number of outputs. So we're going to multiply 8 by all of our outputs and see if that's our function rule. So our rule could be 8 times each input, which in this case is H. So our rule is probably going to be 8H. But let's check. So our first H is 1. So 8 times 1, does that give us our output? Yes. 8 times, instead of H, we're going to put a 2. 8 times 2, does that give us our output of 16? Yes. 8 times 3, the next input, does that give us our output of 24? Yes. 8 times 4, does that input into this rule give us the correct output? Yes. So that means that our function rule for this function is 8H. So the function rule is 8H, but then to make it into an equation, we have to use our output variable also. So to make it into an equation, we say our outputs, D, is equal to 8 times every input. So this would be our equation, and this is our function rule. Okay, so now we're on page 406, example 1. Write one-step equations. The table shows the total cost, C, in dollars of buying T souvenir t-shirts. So we want to write an equation to represent the relationship between C and T, our input and output, or independent and dependent variables. So step 1, identify the variables. The independent variable is T, number of shirts. The dependent variable is C, total cost. So now we want to find the rule. Remember, we have to do change in output over change in input. So let's check the change in our output first. So 9 to 18, the difference between those, or the change, is 9. The change in 18 and 27 is 9. 27 and 36, and 36 and 45, they're all 9. Now we have to check the change in our output values. These all change by 1. But we have to check because we could have a table that has 9 and 1, and then 18 and 2, and 27 and 3. And although they're different numbers, if we did each change in output over change in input, they would all still give us 9. So again, change in output is 9 over change in input is 1. So that gives us 9. So now the number that we get, we're going to multiply by our inputs, just like we did in the previous problem. So our function rule is probably going to be 9 times the inputs, which is t. We call the inputs t for this problem. So now we have to check. So I'm going to make another little column. 9 times 1, that gives us 9, so that works. 9 times 2 gives us 18. 9 times 3 gives us 27. 9 times 4 gives us 36. 9 times 5 gives us 45. So that means the function rule 9t, it works. So that's our function rule for this function. So I'm gonna write over here, example 1, the rule is 9t, but then we need to write our equation. So to write our equation, we need to include the dependent variable also, which is c. So we're gonna say c equals 9 times t. So the equation, we just set it equal to the dependent variable. So this is our rule, this is our equation. So now on page 407, just try this check problem at the top. So now we're on page 408, write two-step equations. Sometimes the relationship between two variables cannot be accurately described by a one-step equation. In those cases, check to see if more than one operation is involved. Consider the following scenario. An online store sells baseball bats. You will pay for each bat that you order plus a one-time shipping fee. The table shows the relationship between the number of bats ordered and the total cost. Write a two-step equation to represent the total cost C to ship an order B baseball bats. So we're gonna have the same first step as we did for the other ones. We wanna find the change in the output over the change in the input. So the change in the output is +2, +2. Then the change in the input, +1, +1. So every output over input is 2 over 1, which is 2. Now we use this number to multiply all of our inputs, just like we did in the last problem. So the first part of the rule is going to be multiplying this with our inputs, which are B in this problem. So our rule is going to be 2B, just like we did in the past two problems. So now we're going to do 2B with all of our inputs and see what we get. So 2 times 1 gives us 2. 2 times 2 gives us 4. 2 times 3 gives us 6. So if you notice, using 2B gives us 2, 4, and 6, but we need 6, 8, and 10. So remember, every two-step equation uses multiplication or division and addition or subtraction. So we have multiplication, now we need addition or subtraction. So if we look at the first one, we get 2, but we need 6. So another step we could add is then to add 4. That's going to give us 6. But now we have to see if that works for all of them. So if I add 4 here, does that give us the correct output? Yes, 4 plus 4 gives us 8. If I add 4 here, does that give us the correct output? Yes, if I add 4, we get 10. So not only did I multiply every input by 2, but I also added 4. So if I multiply this by 2 and then add 4, I get the correct outputs. So that means our rule for this is 2B plus 4, which is a two-step equation. The two-step rule. Now to make it an equation, we have to set that rule equal to our dependent variable, which is C. So the equation is going to be C equals 2B plus 4. And then this is our rule. Okay, so now we're going to do example 2 on the top of page 409. The table shows the total number of necklaces Ari has made after a certain number of hours. Write a two-step equation to represent the total number of necklaces N she will have made after H hours. So again, same first step, find the change in the output values over the change in the input values. So these all go up by 1. These all go up by 2. So then we have 2 over 1 is 2. So now we know that the first part of our rule is going to be 2 times each input, which in this problem is h. So the first part of our rule is 2h. So now let's see what happens if we multiply all of these by 2. So we get 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. So now we have 2, 4, 6, 8. We need 5, 7, 9, and 11. So now what we can do is add 3. That would get us to 5. Add 3. That would get us to 7. Add 3. That would get us to 9. Add 3. That would get us to 11. So we did 2 times each input, and then we added 3. And that worked to give us our output. So this will be our rule. And then again, for our equation, we just set our rule equal to the dependent variable. So we get n equals 2h plus 3. Remember, equations need to have an equal sign. Okay, so last thing we're going to do is you guys are going to do this check problem at the top of page 410.